že já vás vítám na dnešních pohrobách. A během 20 minut vysvětlu to, že máš projekty.
Okay, first of all, ladies and gentlemen, welcome to this presentation. My name is Martin Tasek. You might have gathered by now that this presentation will be led in English. And I'll be talking about our software project that is called jInfer, which stands for the Java framework for XML schema inference. First of all, for you that are not familiar with this topic, what is XML schema inference? Our goal, our top level goal, let's say, is to get from an XML schema or XML document or documents and somehow infer the information about the schema that is somehow described by these documents and get to the schema that we can use later. What we have today is a list of articles dealing with this, I should say, still open topic. But the problem here is that it is really not easy to implement these algorithms described in these articles, to compare them, to see how they work, to be able to work with them. What we would like to do from a computer scientist's point of view is to enable people to implement algorithms for articles like those that will be inside some kind of a framework where it will be easy. You will have some tools at your disposal, and you will be able to easily compare, implement, try. So this is where jInfer comes into play. jInfer is a framework, first of all. It's strongly modular. It works like this. It takes input documents, XML documents, input schemas, perhaps queries, such as xquery or xpath. Then it does the magic, it does the schema inference, and in the end, it outputs this schema in one of several formats. So the technology we use is basically, the thing is, Java already provides things like SAX or DOM parsers. It has, for example, JAX-B, XML binding, etc., etc. So Java is a language, and then we wanted some kind of application platform where the choice is basically between NetBeans and Eclipse. And for personal preference, we chose NetBeans. Moving on, the architecture. I'll describe architecture in 3 views. The first view will be data, then the process, and then the platform view. Data view. First of all, we implemented a regular expression representation. This is a tree representation. It is generic, and it allows us to describe or to represent basically any kind of regular expressions. The important or interesting part here is that we represent so-called permutation, which, for example, in XSD is represented by the XSO element. So there is a simple regular expression, and there is a tree representation of this. I think there is not much to add. We need to represent XML documents, which basically are trees consisting of 3 kinds of nodes: elements themselves, attributes, and text nodes, text data. We divided these 3 types of nodes in 2 divisions. The first division is whether they do or do not have content. The first one will be the elements and text nodes where we have some kind of structure, and then we have textual nodes that are attributes and text nodes again. Then we can divide these types of nodes based on whether they do or do not have a name. The first one will be element and attribute, as they have a name, and the second will be without name, which is the text node. So this boils down to this simplified class diagram of our interfaces and classes. You can see the main 3 classes, representing the XML nodes in the bottom, with the attribute, simple data, and element. Moving on to rules and wrappers. When we have an element, we we represent its content model as a regular expression. Then we can say that this element is a rule of a certain grammar, where the left side of this rule will be the element itself, the element type. The right-hand side will be the content model of this element, and we got two rules. A set of rules will be a grammar, and our framework works with extended context-free grammars. So this is a simple example. On the left, there is a simple XML file, and on the right, there are rules of this grammar that are produced from this XML file. Then, for reasons of schema inference, we needed to implement our own representation of non-deterministic finite state automata, which we did. We support all these usual things like states and transitions. And moreover, our implementation supports state merging, which is useful in certain algorithms that you will see later. Okay, the process view is basically divided into three main parts, main boxes. These three, I need to stress, are sequential. That means that the first step has to finish completely before we move on to the second step, and so on. The first box, the first module, is called initial grammar generator. It takes input files such as XML files, DTD schemas, XPath queries, and so on, and it creates a list, a grammar, of these simple rules that can be extracted from these input files. This is called initial grammar. Then we need to do some kind of magic. We need to do the actual inference from this initial grammar. We need to generalize it. We need to make it somehow, the regular expressions themselves will be more complex, but it will be shorter and more cohesive, comprehensive. This is the part where most of the user interaction will happen possibly. The last box of these three is a schema generator that will take this simplified grammar and export it to a variety of possible output formats, such as, again, DTD schemas, XML, XSD schemas, schematron, for example, this language. When I mention boxes and modules, this means that the actual implementations hidden behind these three interfaces are interchangeable. We did this, the framework is ready for this, and you can always select which actual implementation you will use while performing the inference. And inside each of these boxes, you can start doing this division like recursively. You can go on and create smaller boxes that will be hidden inside the larger boxes. I'll get back to this later, and we did this. So the platform view, we are a NetBeans platforms project, let's say. This means that jInfer is distributed as a set of NetBeans platforms modules. It is heavily integrated. We have NetBeans project type, jInfer project type. This is something similar to the usual Java project type, C++ project type, I don't know, HTML project type that you can get in these IDEs. We have a jInfer project type. And to achieve this modularity, we use lookups, which are the mechanism that is provided by the platform for us to be able to change implementations at runtime. How this works, it's very simple. When you want to implement a so-called service, you just need one interface describing the service, you implement it, you annotate these implementations, and then using the NetBeans, you can retrieve a list of all these registered implementations of this service. Okay, right now I'm handing over the floor to my colleague that will show you jInfer in practice.